joining us for another installment of the Critical Lowdown from EPS Global. So I'm Barry McGinley and I'll be your host today. So I'm the head of technical for EMEA. I've been with EPS now for nearly 7 years, working on POCs in the data center market and service provider. So content, ISPs, managed service providers, everybody basically. So today we have a podcast on scale, innovate, profit, open networking for cloud and managed service providers. So we're going to look at scale, innovation, and profit for cloud and managed service providers within the kind of open networking realm. So today as well, I'm joined by two great guests. I have Prasanna. Hi, Prasanna.
Yeah. Hi, Billy.
Hi. So Prasanna is from IP Infusion. And then I have Kai Lee from Eufy Space. Hi, Kai.
Hey. Hi, Barry. How are you?
Great. I'm really good. So thanks for joining us, guys.
Sure.
I think we have hardware and software, so we've most of the bases covered for the questions we have today on the topic. So a little bit on introduction. So Kai, welcome and thanks for joining. And can you start by introducing yourself, your role at Eufy, and a little bit about Eufy Space as well and what Eufy do?
Yes, absolutely, Barry. Thank you. My name is Kai Lee. I'm responsible for the technical sales here in Northern California. Been with Eufy Space for a few years, and a little bit of background of our company. Eufy Space been around for about a decade, for about 10 plus years. And we focus mainly on two lines of business, the data center and also the telco for the carrier. And we focus on hardware and firmware design using open disaggregated solution, meaning we leverage off-the-shelf merchant silicon from the industry, both the data plane and the control plane, and also other supporting technology around the white box. And later on today, I'm going to talk a little bit about why the open disaggregated actually makes sense in today's environment. But that's what the company focus on, and then I'm very excited to be here today. Thank you, Barry.
Brilliant. Thanks, Kai. And Prasanna, same question, I suppose. Introduce yourself and I suppose your role at IPI and a little bit about IP Infusion. I know we've had them on the podcast previously, but if you can go into a little bit of detail on IPI as well.
Yeah. Thanks, Barry. So I'm working as a technical marketing engineer for IP Infusion. Right. So before joining as a technical marketing engineer, so I was into the development for 2 decades almost, and I have been doing with the EVPN VXLAN from quite long. And I have been with the IP Infusion, for around 12 years, right? So IP Infusion, it's been into the network operating system from quite long, like more than 20 years. So we have been providing software for the ODMs, right? And now, from quite like 8 to 9 years, we have been into the disaggregation space. And we are providing the solutions from access to the core throughout. And it's been great, to be part of, with the Eufy Space and EPS, right? So let's have talk together, what we can do.
Great. And actually, I'm always a little bit surprised when I hear how old IPI is, because it's kind of older than open networking. And actually, I'll ask you a question on this. So understanding open networking. So what is open networking and how does it actually differ from traditional networking?
Yeah, this open networking is something, very, very amazing one, because we put together, many of the open things, we talk from, from the northbound, right? From the management, it comes with the open config. And then, we have a, open NOS, right? So open compute network operating system, which talks to the management. And then the NOS talks to the, the open compute hardware, right? And then the open compute hardware then talks to the open optics. So it's a open everywhere. It's all been, working together with all these standards together. So that's where actually, disaggregation comes. And then it provides a greater flexibility in terms of, many vendors coming together and they can provide their own solution and they can achieve, the niche in their areas. And then combinedly, we can have a beautiful solution, very cost effective, right? And a lot of innovations can bring in, because each one is working in their own area, and because it's a small one, right, each area, so they can really innovate very well and they can provide a very good value to the users. So in this way,
Yeah,
open network is very good.
yeah, and as well, something you mentioned having multiple. So you've hardware, you've open optics, you've software, but you guys as well, the way you've done it is you've actually kind of done bundles as well, because it's great having hardware, having software, I can buy them. They're open, they work in anything, but having one phone number to call, having one support. So I think IPI has done really well in the market, having bundles. So if it's a hardware problem, if it's a software problem, you call IPI. So it actually does take some of the hassle out of open networking, and the benefits of going with multiple vendors. You can actually, the support side of it is quite important, that it's one vendor, which you guys do, which is great.
Thank you. Thanks for the compliments.
Yeah. So Kai, so we hear this is to do with open networking again, but like there's so many different names for open networking. So we've always called it open networking, and then when the telecoms got involved, so TIP and the ONF, they started calling it disaggregation and disaggregated networking, or bare metal networking. So can you explain the concept of disaggregation from the hardware perspective,
Sure.
please?
Yeah, sounds good. So traditionally, when you look at our OEM, before open networking become, the kind of momentum that we have today, the OEM pretty much dominate that market for many, many years. And then to first answer your question, open networking disaggregated basically is one major concept, Barry, and that is to decouple the hardware and software. And why are we doing that? And it's for the benefit of the end user. They are having choice to pick and choose what type of hardware versus what type of software. I myself actually used to work in the OEM technical sales industry for many years before UFISpace. In those environments, you pretty much are being packaged by the vendor solution. Okay, here's the hardware and software bundled together. Regardless, you need those software feature or not. You need to pay for it. The software image is pretty large compared to like the IPI Atlas, because the customer now, with the decoupling of the hardware and software, the benefit is you can pick and choose. I want this type of hardware. I want this type of merchant silicon from this type of performance. But I only run, for example, I'm kind of using this as an example. I only run BGP. I only run MPLS on my network. Those are the only routing protocol. I might need a couple other features, so I can pick and choose with an open disaggregated software company like IPI. Then as a result, the software image loading onto my hardware is a lot more small size, a lot more efficient than if the traditional bundle solution. You might end up having a really large software image and maybe 30-50% of the feature you might not need, but you have to get the solution as a bundle. So that's the advantage, and that's how we define open disaggregated.
Yeah, okay, choice. Yeah, that's the way we've always kind of described it to our customers as well. They have a choice. Obviously, there's some software is better than other software. Some are more mature, like IPI, we're saying is older than open networking. But yeah, that's thanks for that. So I suppose we should get on to what we said we were going to talk about. So I think that the title was Scale, Innovate, and Profit. So let's actually have a look at scale first. So this is kind of, we're looking at data centers and service providers, managed service providers, content service providers, and so on. So Prasanna, so there's always challenges scaling any network, no matter where you are. But what are the kind of key challenges for cloud and managed service providers when they're trying to scale their network?
Yeah. So thanks for the question. So this is one interesting, because growing, the data, right? So which brings in the capacity expansion, right? So for the capacity expansion, the technology wise, their existing legacy L2 networks, right, which having, the lesser capacity of the switches, they are a challenge to replace. And L2 also poses some challenges. And also the resource planning, right? And when we say resource planning, again, whether we are, we are with the vendor lock-in with the traditional vendors, right? And then the high network infrastructure cost, and then the long lead times, and then the management complexities. So all these things will add in. And then, from where to buy what, and devices. So all these things will make it more complex in terms of the challenges one faces.
Yeah, and as we've always said to our customers, because the bare metal hardware, you can actually put some spares on a rack for yourself. You don't have to have the software on them. You don't have to have the latest image. And then if something breaks or you want to scale, you take one off the shelf, you put on the NOS and put your licensing on and away you go. So, Kai, so the question to you, how does open networking enable service providers to scale their infrastructure more efficiently though, on the hardware side?
Yes, absolutely. Open hardware basically has a very important concept. It's based on off-the-shelf merchant silicon. And that is very different than the traditional OEM with the ASIC. That's the application-specific integrated circuit, which is very vendor-specific. And the reason we can do it today, Barry, and not maybe 10 years ago is merchant silicon has get to the point they have so advanced in terms of feature, in terms of capacity, in terms of power saving. So we leverage that trend from the open merchant silicon and then take advantage of the economy of scale. We were able to build the hardware to have the kind of level of performance, but at a very economical cost, and then we can pass those to the customer. I also want to add on top of something I said before is the decoupling of the hardware and software and how that help with the managed service and the cloud service platform. And by the way, allow me to spend maybe 30 seconds on that. We look at the managed service and the cloud service similar, but not exactly the same. We deal with both type of customer. Managed service tends to be a little bit more personalized. If I'm using like a managed service from a carrier, I can tell them I want this and not that. Cloud service platform tend to be more like template. You might have heard of things like infrastructure as a service, platform as a service, or even software as a service. So they kind of like very cookie cut. To take advantage of those models, so we were able to build our hardware based on the scalability. And then when you go into the managed service or cloud service, three things always come into the picture: power, cooling, and space. Merchant silicon type of design allow us in a disaggregated model that we build these devices in a 2 RU or even sometimes a 1 RU box. It makes the scalability and the power and the cooling to be a lot more efficient. And last but not the least, another advantage is we make this thing very scalable and very flexible because we decouple the hardware and the software. And because the way how the architecture is built, we call it as a pay-as-you-go model. So let's say you started the managed service or the cloud service with let's say 100 user or 1,000 user. The model allows you to scale up to a couple thousand or even tens and thousands of users at some point without changing your infrastructure. So those are the few key points that I'd like to highlight and share with the audience.
Yeah, okay, thanks. And I see the off-the-shelf merchant silicon, big long name. We can just say Broadcom. I know there's Marvell in there as well, but basically, yeah, in fairness to Broadcom, they've been brilliant on the ASIC side of stuff, like trying the Tomahawk 5 now, and the power of these things is quite incredible. And they're even ahead of Moore's Law, the way they're churning out these ASICs. So thanks for that. So innovation. So let's have a chat about on the innovation side. So Prasanna, so everyone's always looking for an edge, especially in this market. It's in every market, but especially in this market. How does open networking help data centers kind of innovate compared to the traditional approach of doing a data center?
Yeah, it's an interesting question. Thank Barry. So the open networking, actually, the first thing it addresses is, the scale. And in terms of, the standards, if we take, it helps in the optimizations, right? And it also gives a better cost and better lead times, right? So the another thing, which the open networking brings in is the faster software and hardware releases, right? And comes with a lot of innovations to meet, the demanding network requirements in terms of, it could be more data or, more faster responses, right? So the innovations are happening in both the ends, like happening in the software as well as in the hardware. And the end customer is, the free to choose, what he requires for now and for tomorrow as well. So that's what, the open networking actually offers.
Okay, actually, and I'll continue on, Prasanna, with yourself, because I know you're more on the technical side. So So EVPN over VXLAN. So it's one of the buzzwords for data centers, along with Rocky and obviously AI. We're just seeing AI absolutely everywhere. Can you explain EVPN over VXLAN and how it simplifies network operations, again, compared to the traditional approach that's used?
Yes. So if we want to really understand EVP and VXLAN, right? So we need to look back. So the long back, VLAN has been introduced as a network virtualization, right? So that's been very well accepted in the networking world, and people were very happy with that, right? And they embraced and they deployed it very well. So now what we have is, the more than the 90% of the, the medium and the smaller MSPs and data centers are still with the L2. So VLAN is very good, but it is similar to, if we compare to the computing industry, it is like a multi-threaded option it has provided, right? So now we are in a different era, right, where we have seen a lot of hypervisors coming into the computer world to meet the the data demands, right? And Dockers, etc. So a lot of virtualization have come into there, and we have accepted it, right? So to meet the data demands, so the network also need to grow to serve all the to the connect to the customer, and then to the the service whoever is providing, right? So in terms of that, the network virtualization overlay, so it brings in more virtualization in the networking world, right? And it actually helps in connecting different L2 and L3 networks, and because it connects over the L3, right, as an EVPN VXLAN as such, it builds an overlay in the L3. So L3, the advantage we get is, it's a loop free and the shortest path networks are guaranteed, all right? So you don't have to deal with the L2 VLANs and then the looping and then the blocking. All these things are gone, okay? And this is just an overlay. And when you bring in EVPN, right? So the EVPN provides a lot of services over the overlay, whether you take a L2 VPN you want to build, or the L3 VPN, or a club of it, kind of an IRB, and then bring multicast. There are a whole lot of RFCs, coming in to bring in all services which are outside of the EVPN, and they are trying to bring in EVPN, and then we will have a beautiful managed service from end to end, from the the cell site router, service provider, or the transportation in between aggregation, and then the cloud it comes. So everywhere the EVPN can be in the single beautiful control plane. It can control, and then it can provide all the services which are required. And when it comes to the data center, right, so the class fabric with the EVPN VXLAN and in the unnumbered interfaces if you use, right, it provides a beautiful and very simplified way of managing and scaling the as per the demand. So as Kay explained, right, so growing as per the demand. So that is what the class fabric brings in. So if my demand is increasing, I can keep expanding my leaf and my spine. So that's the beauty of EVPN VXLAN with the class fabric. It comes and it helps the data center.
Great. That was actually a brilliant description of it, because it's not the easiest thing in the world to explain. Kai, I've got a tough one for you now, actually. So sustainability, right? Every boardroom in the world is talking about sustainability. So how does UfiSpace's hardware enhance the sustainability of data centers when we're looking at green initiatives within a data center?
Sure, sounds good. Well, we already talked a little bit about the hardware flexibility, in a minute ago. And let me start just with that, because of the scalability and all that, and the time to market, that brings into the sustainability. So a couple key things, as I mentioned previously, the cooling, the power, and the space. When we design our hardware, we focus a lot of thermal simulation on the hardware in terms of the airflow, power management, and all that. So if you look at the hardware design of a switch, you have the data plane, you have the control plane. Traditionally, the control plane are the Intel processor, which is where we are running the, for example, IPI software. And then the data plane will be the merchant silicon, which, is taking the instruction from the control plane to push packet on the data plane back to back to back. That's how fundamentally how the switch works. To answer your question on the sustainability on power management, cooling, and all these other things, we actually have a separate processor called the BMC, a board management controller. And that we call it the distributed architecture. We don't bother the data plane or control plane to do those housekeeping. We have a separate processor to do that. And when we do our design, we do a lot of thermal simulation, how we control the airflow back to front to back, and how we actually design those flow with the venting hole. We call it the venting hole, micro venting hole technology. Is really tightly control where the air flow sufficiently. And the other thing, this is something people might not pay a lot of attention, is the BMC with the fan design. We have multiple fan on the cooling, usually it's N+1. Now, traditionally, a lot of network design, you have a fan, you have a couple of them, and you are sucking air. We call it the CFM, the cubic feet per minute from the front to back or back to front. With this kind of intelligent management for sustainability, the BMC actually have temperature sensor. We sense, let's say, if the temperature inside the box go up to a certain degree Celsius, the fan actually kick in at a higher RPM until the temperature drop down to a certain threshold. Then we slow down the fan, we save the energy, we reduce the noise. So those are the things that become very dynamic and very intelligent and dynamic in the sense that we adjust based on the environment inside the data center or inside the central office. So those are some of the examples, Barry, that have built into the intelligence of our hardware design.
Now that's really interesting on the BMC chip, because obviously, like I remember looking at 1 gig switches kind of 15 years ago on the size of the fans. I'm looking at 400 gig routers from you guys now, and the fans aren't that much bigger than they were, and obviously the heat coming from these optics. So really smart to have that intelligence inside the box and not just relying, excuse me, on the temperature sensors in the data center. So the final area, okay, and this is the important one, is profit, right? So it's all about money in the end for these guys. So Prasanna, can I ask you, so what are the key benefits of adopting open networking for data centers, be it for cloud or managed? So what are when we're looking at profits?
Key benefits are, the first thing is, it slashes the costs, right? So the white box networking, yeah, and then it comes with the, the open hardware, open software, and then open optical system, and then the open config, and you'll get the open controllers, right? So everything is open, and you can choose it from different vendors, and whichever suits the, the requirements, and whichever meets the data demands, right? So all that can be done at a lesser cost because many providers will come, right? And we are not bound with the traditional vendors, right? One box solution, everything. So that's where, it reduces the cost. And in terms of CapEx and OpEx, right? So in terms of the CapEx, because we have multiple vendors to choose from and a lot of innovations are happening, that's why we are getting, the bigger capacity in a small form factor with respect to the price and the size. And OpEx savings, because EVPN VXLAN is coming. So once they have operator is having an EVPN knowledge, right? So he can work through from the service provider aggregation side to the data center core, everything, right? So that's where the, his experience helps. And operational efficiencies because of, the lesser delivery times, right? And when it comes to the IP infusion, so our software, right? So it is having the industry standard CLI. So it will have a lesser learning curve in terms of, when it comes to OpEx for the operator to learn and adopt it, right? And the other thing is the faster deployments to meet the need and the faster demand. So this is where, the end user get all the benefits of, the open networking.
Yeah, no, that's a really good answer, and something that we've found with our customers as well, not having, I suppose, some of the licensing models that some of the bigger vendors would have. Like you've one upfront payment, you're paying for your switches, you're paying for the license on the switch, and then there's a small support contract depending on your 1, 3, 5 year needs. But it's one upfront payment. There's not this kind of thing every year, and I need another feature, I have to pay for this. So there's nothing surprising about it. It's all upfront and above board, I think so. So Kai, so something we hear about all the time is vendor lock-in and open networking. You don't have vendor lock-in and the benefits of it. So can you actually say what the financial benefits are for avoiding vendor lock-in? Yeah,
sure.
Please.
Yeah, that sounds good. So I will summarize this into 2 key points. The first key point is a pay-as-you-go model, Barry. As I mentioned, when you look at a data center or central office, power, cooling, space, those are the 3 very important things beyond the technical design of the box itself. So the pay-as-you-go model, when we do the open disaggregator, if you look at our device or most of the open disaggregator model in the industry, they are usually 1 RU or 2 RU. They are not a big chassis. So this allows us to build the infrastructure with a pay-as-you-go model. So let's say you started the scalability with your managed service with the kind of user in the hundreds, you can easily scale up to the 1,000 or even higher. And the important thing is, Barry, it doesn't change your existing infrastructure. You can build on top of that. So that the pay-as-you-go model is very important. And the other thing we also look at is the CapEx versus APEX. That's a key point number 2. Let me address the CapEx. That's a no-brainer because it's off the shelf. Because I'm no longer building an ASIC just for my own company. I'm using off the shelf. So the scale of economy of everybody leveraging this type of merchant silicon, I will be able to build my device at a lot less lower cost, still preserve the type of performance. And that's why open disaggregator model catch a lot of momentum, including some of the very large customer in the industry are looking into it. Merchant silicon came a long way, Barry. If you look at it in the last 10 years, they really catch up with some of the bells and whistles compared to some of the specific ASIC design. That's the CapEx. On the OpEx, and I like to use an example, in a closed lock-in model, if you assume I'm still, with an OEM vendor, I actually sell you 3 things, Barry. You have to get hardware, bundle software, and the last thing is a service support contract from me. If you buy my hardware and software closed bundle, where else can you buy my service contract? You only can come to me because it's a closed system. So from an OpEx, because it's decoupled from a hardware and software, so the service contract cost, the OpEx cost actually kind of reduced quite a lot. For example, you said it well a minute ago, Barry, that you said in this environment, people can come to IPA, you kind of become the system integrator as a one-stop shop for the end customer. So that actually reduced very large the maintenance cost or the OpEx cost for the customer. So those are some of the key benefits. And the last thing I'd like to leave with you or the audience is, being in this business for a long time, I learned one thing: financial decision always drive the final technical decision. If this makes financial sense, eventually things will move. And I also learned one thing in my career. I don't know why. CTO always report to the CFO. So I think that addressed the story.
Yeah, I completely agree with you there. I don't like when customers come and it's all about cost savings, but in the end, that's what it is. And the off-the-shelf silicon has allowed, like the OCP for the last, 14 years, has allowed companies make hardware for cheaper, and that's the goal. The goal is everybody using the same stuff, and will drive the price down for the consumer. So it is working.